Hello, my name is Marco Greco. I am based in London. I'm a software architect for the Nickel team, and today I'm going to be talking about user-defined functions in Nickel. So what we're going to cover is a quick overview of the feature, and then the general operation, and then we're going to touch on two different languages that we support. The interaction with collections, which is the big feature in 7.0, and then a few tips and tricks on debugging and other stuff. So let's get right down to it. If you think about SQL and Nickel, they are declarative languages, which has been the big revolution in terms of databases. So you never explain to the engine what it needs to do. You just say what you want, and the engine will work out the query plan and the execution and basically just give you your results, which has been fantastic in terms of handling data, but has one issue, which is the bespoke business logic. You know your own business logic. Nickel doesn't know it. So by not having the ability to extend the language, it cannot do certain things that you want. And this is where user-defined functions come in. So they give you the option of specifying some logic which does not exist in standard functions. And this has been something that's been done in multiple database engines. And as you can expect, it's been done in the analytics service, and we share the same syntax. So what you have to do is create, drop, or amend your own functions. And then once you have them defined, you can execute them. And you do that through some layer, a new layer in the Nickel engine called the Language Manager, which supports multiple languages. The one that we expose are called Inline, which is a Nickel language, and Javascript. And you've got the option of executing your UDFs in standalone mode or as part of Nickel statements. There's a major difference in between the two. In standalone mode, you can actually change your data. These are called side effects. If you're using select statements, this cannot have side effects. So the UDF mustn't do anything of the sort, or you will get errors. Just some Nickel syntax to see how you handle functions. So there's the create function statement that takes two forms. One is a more compact for the inline language. The other one specifies the actual language. Then there's two modes of executions, and finally drop function to drop the function. And if you pay a little bit of attention there, you will see there's a difference between create function and drop function in that in drop function you only specify the function name, and there's a reason for that, which we will see in a second. So delving a little bit more into the operation, we have got multiple types of functions which are differentiated by the parameter list that you're going to pass. And you can have either functions with a fixed number of parameters, and in which case the parameters are named. And when you create functions that are being created this way, when you invite functions that are being created this way, the argument count is going to be enforced. If you specify a number of arguments which is different from the number of parameters, you're going to get an error. Or you've got a more flexible type called variadic functions, which take any number of arguments, including none. And these are denoted with a triple dot parameter list. Variadic functions are interesting because they allow you to simulate functional overloading, meaning you can create a function that handles different number of arguments and behave differently. And this makes them similar to object-oriented database engine functions, in which you can have functions with different signatures which do different things depending on different types. The other thing that is important in functions is return values. Now, if you have a look at most database engines, they will allow you to create functions with multiple return values. In Nickel, you can only have one, which is consistent with the standard functions. But this is not a limitation in that if you want to return more than one value, much like you would do in a relational engine, what you can do is within your function is you can combine all the values that you want to return into an array, which is a value. If you want to return, say, multiple documents, or if you want to return a structure, you can just create a JSON object and that returns values arranged in a structure. So same functionality in a slightly different delivery. The other thing that we need to talk about is signatures. So in general terms, in relational engines, a function would have a signature that's made of the name and the list and type of parameters. So when you're executing a function and passing a certain argument list, the relational engine would look for a function which has got that list of parameters and types and basically choose one. Not so in Nickel. We only ever have one copy of the function. JSON doesn't really have a fixed schema, so we can cast from one type to another. And we will just execute that function, and that function is expected to handle the different types. So when it comes to creating it, dropping it, replacing it, you still use the same name, and we disregard the parameter list. And that's because with a flexible schema and untyped parameters, literally, there's no need for the more complex extensibility that's implemented by more traditional relational engines. So once we've got past the DDL, how do you execute a function? Well, as we were saying, the issue, the principal issue with functions is that if you use them within a select statement and they have DML of some sort, insert, update, delete, those are considered to be side effects. And side effects are bad for select statements. So if you're using a JavaScript function and this has side effects, when you execute it within a select statement, as soon as you hit the first DML that you're executing in the Nickel function, in the JavaScript function, you will get an error. So two modes of executing functions, select or execute function. If you've got side effects, you've got to use execute function. Last but not least, privileges. When you are managing and executing functions, you need three different types of privileges. The first thing is you need privileges, specific privileges to manage the functions. Unless you've got the rights, you cannot create functions, you cannot drop functions. Further, we differentiate rights in between functions of an internal nature and an external nature, and I will cover this in a bit, and a global and scope nature, and again, I will cover this in a bit. But also you need specific rights to execute functions of different types. And that's because functions could actually do dangerous kind of operations, which you want to limit to specific users. So there's a whole number of privileges that you can find in documentation. I'll give you a couple of roles to execute and manage functions. So one would be, for instance, query execute functions, and that allows you to execute functions in a specific scope, or much more complicated query manage global external functions, and that gives you the opportunity to create JavaScript functions at the cluster level. Now, on top of that, you also need all the privileges to execute whatever nickel statement your function executes. There's no cascading of privileges from the creator of the function to the user that executes it. All the rights need to be assigned beforehand. Now, with that, we're going to switch to the different languages, and we'll start with Inline. Now, Inline is a very simple language that allows you to create a function with one expression. Now, this sounds quite simple, but in actual fact, the expression that you can use can be as complicated as you like. So it could be anything like a simple arithmetic expression to a very complex conditional expression to a downright select statement. They are, if you think about common table expressions, as in the with clause in the select statement, they are a way to specify a common table expression and kind of storing it so that you can reference it in multiple statements, and you can basically standardize code across multiple statements. And the advantage being that if you need to change the function, all the statements that use that function will be amended at the same time. So Inline, as I was saying, is known as an internal language because it executes inside the Nickel engine. It is executed by the expression and execution layer of the Nickel engine. And as I said, it does not accept any DML. So it doesn't have side effects, and it can be used safely in any sort of circumstance. And again, the big advantage of the inline functions is the fact that you can use it to implement some polymorphism. So where you specify an interface, which would be the actual function name, and then the behavior is different across the different implementations of the same function, and we will see this in a little bit. Again, an example of the syntax. We've got two forms. The first compact form, which basically allows you to specify an expression in braces, and then the second, more complex form, allows you to specify the language clause, select the language, and then specify the body of the function as an as clause, depending on the language in use. JavaScript functions are much more rich than inline. They allow you to use any valid JavaScript to create complex logic, but they have a whole bunch of issues, in a way, attached to them. The first thing is JavaScript is an external language. What that means is that JavaScript functions are run by a JavaScript runner, which executes inside the Nickel service as a separate thread, but it's completely separate from the Nickel execution layer itself. So what that means is that although Nickel does know that the JavaScript code exists, it doesn't have visibility of the code. It cannot manipulate it. It can just call it. The other thing that I need to point out about JavaScript is that the runner is not fully developed yet. So there are certain limitations at this moment in time, which will be resolved in later versions. So let's move on to operation. You have got two aspects to handling JavaScript functions. The first part is the definition, and this is specific to JavaScript. The second part is using it, and that is the same as any other language. You could, in fact, create originally an inline procedure, use it, drop it, recreate it as a JavaScript function, and Nickel wouldn't be any wiser about it. He would just use the procedure in the same way. So, as we were saying, since JavaScript is an external language, when you create a JavaScript function, you have to follow a two-step process. The first thing is you have to create the JavaScript object. So you have to create a JavaScript library which contains a JavaScript function which has got a specific name. Once you've done that and the object is available, you can then create the Nickel user-defined function. And what you're doing is, with that creation of the function, you're pointing Nickel to the library and to the object. And the advantage of this is that you can basically create one single JavaScript object, and then you can share it among multiple user-defined functions at different levels. And if you amend the JavaScript object, then all of the UDFs that are using it will change as well. And in a few slides, we will see how this is actually useful. So again, a bit boring code, all the steps to create and execute a JavaScript function. First thing first, there's that big curl REST API call to that functions libraries endpoint. And what that does is it creates a library called mat. And as part of that library, it adds a function called add, and that is the body of the function. It just does an add. Once we've got that, then what we can do is create function JavaScript add. That's the Nickel UDF definition for the function, and we're pointing it to the add object at the mat library. In terms of parameter passing, that works in exactly the same way. You can have variadic, you can have niladic, you can have polyadic functions. The syntax is the same, and the arguments are passed in the same way. After you've done that, you use the function much like you would do in any other case. And finally, when you drop the function, you have to do it two steps. So you drop the UDF definition from Nickel, and then if you need to, you remove the library from the JavaScript runner. A quick look at what is going to be implemented in later versions. You're going to have execution of Nickel statements. We're working on it right now. You're going to have a UI to create JavaScript bodies, much like there is in eventing, and there might be a JavaScript debugger as well. Now, we have to touch the interaction of user-defined functions with the collection feature, which is the big feature in version 7.0. What we've talked about so far is simple functions that make no mention of where the function is created. So we kind of have had a look at functions that would be global across the cluster. In actual fact, with the invention of collections, we had to create a new type of function. So we now have functions that are visible at the cluster level, and they're the global functions that we've investigated so far. But you can also create functions that sit inside a scope. The difference is this. When you create functions that sit inside a scope, what you can do is you create the same function in different scopes, which have got the same name, but implement different logic. So I'll give you an example. If, for instance, you are creating a function that calculates sales stacks for some items, and you've got different scopes in your bucket, one per each country. You could have a sales stacks for the United States, you could have a sales stacks for the United Kingdom, you could have sales stacks for Italy. It would all be called in the same way, but underneath the body would calculate your sales stacks in a different way. The general idea is that then you could deploy different companies in different countries with the same nickel statements, which would call the same sales stacks function, and they would operate correctly for the country that you're dealing in that particular scope. So, how do you distinguish in between different types of functions? So, as we were saying, you have global functions, and those are visible at the global level. And that means that the name, the full path of a global function is just the namespace and the function name. For scope function, we follow the same naming convention as collections. So that is a four-part path, which has namespace, the bucket, the scope, and finally, rather than a collection name, you get a function name. In terms of how you define in your select statement which function you're actually using, this is done in the same way as for collections. So we have to do we have to take a quick detour. So say that you've got a statement that says something on the lines of select star from collection 1. How do you know what collection 1 is, where it is? And you do that with a REST API parameter that's called query context. And query context specifies the path in your request for any object that is not fully qualified. It's kind of, if you think about relational database engines, it's kind of a connection string. So we qualify user-defined functions in exactly the same way as if we would do with collections. So if you're using a full path, there's no ambiguity in any way. 2 parts, that's global. 4 parts, that's a scope function. But if you use a unqualified name like func1 in the example, then what we do is we use query context, and that function is either a global function or a scope function, depending on whether the query context is unset, set to a namespace, or set to a scope. The last thing that I have to mention is there is nothing to stop you from creating a UDF that's got the same name as a standard function. I don't know, let's say object values or array add or whatever. Now, if you try and do that, the Nickel engine will always use the standard function. The ambiguity is resolved in that way. If you want to use a UDF which has got a name as the standard function, then the only way out of this is to use the full path. So you would have to call, invoke your function default object values. Now, I'm not saying that using standard function names is a good idea, but the option is there, and this is how the ambiguity is resolved. The other thing that we have to have a look at is you've got your UDF. That UDF has got a nickel statement, and that nickel statement, and there are good reasons for it, wants to use relative object names. So you want to say inside your UDF, select star from collection 1. So the big question is, how do you resolve relative names for objects inside a nickel function? How do you actually avoid any sort of ambiguity and this behavior? And what we do is we use a similar principle as the query context parameter. So what happens is, when you start executing a function, the nickel runner will switch the query context of the request from whatever it was set to the location where that function had been created. So if you had created a global function, the query context will switch to the cluster. If you had created a scope function, the query context will switch to the scope of that function. So for a global function, an unqualified object is always a global object. So it's always either a bucket if you're referring to a key space, or a global function. For scope functions, it's always a local object to the scope in which that function had been created. If you're using fully qualified names, there's no ambiguity. It literally is what you were saying. And why would we do that? The general idea, again, is that you want to deploy multiple copies of the same application, and you want to create functions that behave in the same way. By using relative object names and pointing them to the scope where that function will be created, you ensure that all the functions behave against objects of that scope, and therefore in a consistent way, and that without having to change anything manually. So the last thing that I want to touch are tips and tricks, not many of them. So the first thing that you can do is actually just alter functions and not having to drop them and recreate them. And this is done with the create and or replace syntax. So what happens is, if you use create or replace, we will first fully qualify the function that you are specifying. So we will get the whole path, and then we will search for that whole path. If we find it, then the function is first dropped and then recreated. If we don't find it, it just gets created. And we only consider the function name and not the parameter list. Again, the signature is the function name. And this allows you to change the function interface if you want to have different behavior. So you don't have to manually drop something just because you want to change the number of parameters. It just happens automatically. The other tip that I wanted to pass on is system keyspaces. So we do have system keyspaces to inspect nickel metadata through nickel. And we have introduced two new system keyspaces, one's called system functions, and if you select star from system functions, it will list all the known functions in this cluster, both global and scope. And the other system key space is system functions cache. The difference in between functions and function cache is that functions cache will list the functions that are loaded in the cache of each individual node. This is more used for diagnostic purposes. If you've got misbehavior, you could actually check the cache and see what you've got loaded and what you've got unloaded. You could even actually delete entries from function cache, and that would refresh the cache. Couple of common mistakes. When you have parameter names and document field names that match, how do you resolve that ambiguity? Well, relational engines, and NQL has taken a cue from that, always resolve a matching identifier to the parameter. And if you have a look at the statement inside the NQL function that I give you in the example, essentially we're comparing type to type, and that makes no sense. What do we mean by one and the other? So in any case, you would have to write a different statement, and you have got two options. One is you fully qualify the field name with the document. So you write something like select star from travel sample, where travel sample.type equals type. Or the more accepted solution is to have a different namespace for fields and parameters. So traditionally, you basically prefix any parameter with a v to signify that it's a variable. And then there is no ambiguity. The other tip that I wanted to pass is that when you have a select statement inside the function, then the return value of that select statement is an array. It's not a scalar. So even though you are selecting one document from your travel sample key space, we are returning to you an array of one document. So if you then compare the result of that function with another scalar, that's never going to work. Basically, your comparison will fail and you will not be selecting what you want. You're going to get wrong results. So what you have to do instead is to return the element of the array. So like in the example, you basically have to append a square bracket, 0 square bracket, to return the actual element, and then that will be a scalar on an object which you can use happily. Last slide, a couple of tips on debugging. The most common things that you're going to see are either unexplained results, this function is not returning what I wanted. Have a look back at the previous slide just as a starting point, or slow performance. So there are a few things that you can do. First thing is get your function, get the body out of the function, and then run explain on it. And make sure that the explain shows a plan that makes sense and not, for instance, a different index or primary scan. Or the other thing that you have to make sure is that the function body executes correctly and returns the correct results. Again, bearing in mind the type. And then, as I was saying in the previous slides, once you've made sure that the plan is correct and the results are correct, make sure that you are using the results from the function correctly in your NQL statement. And with this, I have finished. You can get in touch with me if you have any questions. That's my email address. Thank you very much.